Hi, I'm Mary Chip with Bentley Systems. Today I want to show you how to create a translucent panel system using the curtain wall tool. So recently I was interested in modeling a translucent panel system for a building. Now this is a skin framing system that uses specialty profiles and translucent panels as a building enclosure. The panels are about 4 inches thick and supported by an I-beam type profile. So I created the profiles by creating variations on the standard delivered profiles. And I created the panel by simply creating a panel data group definition that was 4 inches thick and used a translucent part that I created, and then was able to place my system shown here. However, the panel is actually not just a simple piece of glazing, but it's a sandwich panel made up of an internal grid and a translucent face. And that internal grid is missing, and it really changes the whole look of the system. So I decided to make a parametric cell of the panel that would include that internal grid. So let me show you how I did that. So I'm going to open the Mullion Profiles cell library. This is the same cell library I used to create the variations on the profiles. And in fact, there's the Mullion profile that I created. Let me go ahead and open that variables dialog. And so this is our profile variation for this panel system. And note here, this is that panel thickness, 4 inches here. And so the panel needs to sit right in there. So to create the panel, you'll note here over here in my models that there's a number of 3D models that all start with face 4 definition. So this is important. These are parametric panels. There are some that are delivered, and we're going to create our own here. The naming of that is important. Our model must start with face 4 definition. The 4 actually indicates the number of sides to the panel, so that could be a different number, but essentially that's the format. And then after that can be the description of the panel. And you'll note there is one in here named empty, and we could use that as a template, so to speak, and just copy it. So I'm going to just right click and select copy, and then change the name here. So this will be my translucent panel. And select OK. And you can see it already has a little bit of the geometry you need. You have to create basically a rough opening shape, and you build your geometry off that. I'm going to actually just delete all that, and we'll start from scratch because I want to show you exactly how to do this. And I'm going to rotate into an isometric view and just go to the wireframe white background. Now we want to note that 0, 0 origin. We do need to create this panel with that 0, 0 origin at the lower left. Now the first step is to create a shape, and that shape will represent the rough opening of our panel. It essentially means the area between the frame. And I'm going to go ahead and just create that shape on the default layer. Use a little shortcut here. Q1 brings up my level attributes. So I've got the level set to default. I always like to use a color that I can identify, because I'm essentially going to set up some constructions initially, and then we will do the 3D modeling. And so I'm going to maybe create that in a dash line. I like a little heavier line weight so I can see it. And then I'm simply going to draw a rectangular shape, and I just want to make sure I start that shape at the 0 origin here. And then I'm going to rotate my compass to front since I'm working in that ISO view. And I'm just going to create a basic shape here. I'm going to come over about 2 feet and then up about 3 feet. Important to note that Where the shape will be parametric, it will resize itself based on the size of the panel. It will not make a shape smaller than what is shown in the cell. So you want to start with something that's about as small as you would ever make the panel, and then of course it can become larger. The other important thing about this shape is that it needs to have a family and part, and it needs to have a specific family and part. This rough opening shape needs to have the family and part of curtain wall, curtain wall. So just that generic curtain wall, curtain wall. And so we're simply going to now apply that part to it. I don't want to change my symbology, so we'll just select that. And now if I hover over that, we'll see the family and part is assigned. Now I'm going to put one constraint on this shape, and that is I'm going to fix this bottom corner to 0, 0, because we do want that point at 0, 0. So on my constraint modeling tab, there is a fixed constraint here. Select that, and I'll just snap here to that corner. And you can see a little glyph comes in there showing that fixed constraint is on there. Now my next step is to start thinking about some of the variables I might want in my parametric panel. So since I copied this from that empty cell, there are some variables already defined. So for instance, frame depth, and we can see this is just a distance variable. Its current value is 1 inch. And I'm actually going to change that. My frame depth needs to be more like 3.5 inches. Remember, it's a 4-inch panel. And so the frame is inside of that panel, so a little bit smaller. And since it's a variable, that will be adjustable. Another one we'll need is the frame width. Now this is a fairly narrow piece of frame, and I'm going to put in 3/4 of an inch. Now I don't need the louver distance. I'll go ahead and delete that. And I don't need the distance variable. I'm going to delete that. I do want, though, a panel depth. So I'm going to add another variable and call that panel depth. That's also a distance variable, and we're going to put that in as 4 inches. Also don't need these variations down here. We'll create our own in a bit. So those are the three main variables that I need to control this panel, but there's a couple more, and these are actually some different types of variables. So as we create the solid, you'll see that oftentimes we need half the depth of something because we're extruding it in both directions. And so whereas we might define the panel depth, we also want half that panel depth. And so we can do that by creating another variable. So I'm just going to duplicate this one and call it panel depth 2. And we can put an expression in here. So I'm going to click there and then open up the expression dialog. And basically this is some kind of mathematical expression. And we can pick from our existing variable. So I'm going to double click panel depth and then divide and type in 2. And we can test that. It tells me the expression is valid. So I'm going to select OK. And then I can't actually change that value. It's always based on the actual panel depth. So I'm going to do the same for the frame depth. So again, I'm just going to duplicate. And finally, I'm going to create two variables to basically control the array of the grid that we're going to create. So we're going to have a number in the X direction and a number in the Y direction. And again, it'll be something we can control and change. So I'm going to call the first one numX. Now this is going to be a slightly different type of variable, whereas all of these are distance variables. They're defining a length, basically. We're going to change the type up here. And you can see there's other types of variables we can define. And I'm going to make this an integer variable, since it's basically a count on something. And I'll set that to 2 initially. And then again, I'm just going to duplicate and create a num_y. And I'll just change its value to 3 just so that they're different. So now that I have the variable set up, I'm going to start modeling the panel. So I'm going to start by creating that gridded frame. And I'm going to do that by creating a line at 2 edges of the panel, linking them to the shape here so that they are always the same length, and then extruding those into solids for the frame and then arraying them along the path. So I'll start by drawing a line. I'm just going to make sure I'm matched to my construction there, and then select the Smart Line tool. And so basically tracing the shape here. So I'm drawing one line on the left there and one line on the bottom. But I want to make sure I constrain those lines so they always stay with my shape here. So I'll start by making them coincident. So I simply select the coincident constraint and I select the line, and then again, and it will select the shape. And you can see it puts the coincident symbol on there, and we'll do the same on this side. Now, I don't just need them to be coincident, but I also want them to be equal. In other words, if the length of the shape changes, we need the length of the line. So we're going to use an equal constraint. And I'm just going to do the same thing. And that puts an equal constraint on there. And you can test this. You can always test your constraints by selecting that initial shape and then modify one of the points and see if the geometry behaves as you expect. If I highlight that, I can see my new line has changed its length and it's remained coincident with the shape. So exactly what I want. So we'll just Control Z to undo that. So now I have the line set up, and I'm going to use that line to start my solids. So this is a frame. I'm going to set my family in part to the curtain wall frame 1 that I have. I'm going to switch over to my modeling workflow and use my solids tools, and I'm just going to use the extrude. So this creates a solid by extruding a linear profile. So we're going to extrude this a certain distance. We're going to extrude it in both directions because we think of this shape as being at the center of our panel. And I could just type in a fixed distance, or I can use my variables. And in this case, I'm going to use that frame depth at half the frame depth. So we'll select that as the variable. And then for the thickness, which will be the width of my frame, I'll just use my frame width. And that'll be from the center of that line. And then we'll go in both directions. So I'm going to select the line here. And now you may want to rotate your AccuDraw compass so that you make sure you're extruding in the correct direction. So that's the side frame, and we'll do the same for the bottom frame. Again, rotating my AccuDraw compass to make sure I get that extruded correctly. You may want to check for family in part, so it is on the correct family in part. And we may need to just update our symbology. And now that I have that side and bottom frame, I'm going to array those to create the grid. So over on my Modify Features tools, we have an Array Parametric Solid feature. And I'm going to do an array along a path because I have those paths, those 2 lines I created. And so we'll use those lines as the path for the array. and I'm going to array by number so I can control basically the number of grids. And then I'll create multiple variations. So for the first one, again, I'm going to use a variable. I'll use the numX variable. You also want to check that whole element there. And we'll select the line along the y-axis and then the other frame. And there we have our array, and that creates our grid frame. And if you want to test it, come over here and change some of these values. So let's change our num_y to 5. You can see now we have a 5 grid panel. Change numX to 3. So that appears to be working. And the last piece in this is to create the actual panel, the translucent panel, and I'm going to do this by simply extruding the shape, although I'm going to offset this shape and make it just a little bit larger. So I'm going to just do a move parallel. And I'm going to use a fixed distance here. I'm just going to put in 3/4 of an inch. I want to double check and make sure I don't have a family in part on this, because I need this to be the rough opening. I should only have one shape with family in part. So I'm going to actually drop the family in part off of this, and I do that by setting this to none and then doing the apply part. I also want to make sure I constrain this to the original shape. So I'm going to go back to my Constraints tab. So one, I want this to be parallel, all 4 sides. So we're going to do that to all 4 sides. So I select one side and then the second side and constrain those parallel. And I also want to control the distance between those. So I'm going to use my distance constraint here and pick one, then the other. It's going to default to that 3/4 of an inch. Again, I could create a variable for this if I wanted to, but in this case, I'm just going to leave it at 3/4 of an inch. So I just accept that and hit enter. And then I'm simply going to use that new shape to extrude the panel. So I'm going to again set a family in part here. I'm going to use this curtain wall glazing translucent. This is the part I set up with a translucent material. I'll go back to the solids tab. Again, I'm just going to use this extrude tool. My distance in this case, I want this to be the panel depth, but of course half the panel depth. And then I don't need any thickness. It's just the entire shape extruded. So we'll set that to none, and we're going to extrude in both directions. So I simply select that outer shape. Again, rotate my compass so that I make sure I'm extruding along the axis. And again, I'm just going to get the attributes changed. So that's my gridded panel. All that's left then is to create a couple variations that I want to use in my model. And the variations are just going to be the grid, the number over the number. And so I'll go ahead and set up the first one here. So one of my grids is going to have a 2 in the X and 2 in the Y as well. So that'll be a 2 by 2 grid. And so we'll just add that variation. I'm just going to call it 2 by 2. So that's a 2 by 2 grid. And then the second one I need is still 2 in the X direction, but I want one that's going to be much taller. And so it's going to be 10 in the Y direction. And again, we'll just save that variation. So I have 2 by 10 and I have 2 by 2. Those are the two variations. And of course, I could set up any number of different variations, but that's what I need at the moment. Now that I have my variations, I can tie those into my data group system. So I'm going to go back to the Building Design tab. So I'm going to go to my Reporting tab, open up the Data Group Catalog Editor. And I simply need to create two new panels, one for the 2 by 2 variation and one for the 2 by 10 variation. So I'm just going to go to my panels, right click, we'll select a new catalog item. And so I'm going to call this project panel 2 by 2. Now in creating a parametric panel, it's important that you select the panel type as being the parametric cell. I'm going to set the family and parts simply to curtain wall, curtain wall. I'm going to put in my panel depth, which is 4 inches. And then most importantly, I have to link to that profile. So we go to the mullion profiles. And we just need to find our translucent panel, and we want the 2 by 2 variation. And we'll go ahead and save that. And then for the next one, I'll just duplicate this one. And we're going to call this 2 by 10. And then all I need to change is my variation. And we'll save that one. And one final thing you might want to do is make sure that these shapes are not going to end up showing up in your model, and you can do that by simply making sure that they are a construction. If I go to my change element attributes, I can change the class of an element. So I'm going to make sure these two shapes are constructions. And now we'll go ahead and go back to our 3D model, and I'm simply going to replace these panels in my system with the new parametric panel I just created so that we get that grid. So I'll start with the upper ones here. I'm going to select one of those panels. Now I can multi-select the entire line and simply define the range by selecting the bottom mullion and then the top mullion that then defines all the panels. Left click to accept, and I'm going to change to my new project 2 by 2, and then left click to accept that. And we can see now we're starting to see that grid in there. I'm going to do the same then for the larger panels. Again, I can multi-select. If your selection is in the wrong direction, the Shift key will rotate the orientation. Left click to accept. I'm going to use the 2 by 10 grid. Left click to accept. And finally the bottom one. And this again will be the 2x2 grid. And now we can begin to see that panel system more accurately represented in our 3D building model. So that was just a bit of an introduction into creating parametric panels for the curtain wall system. You can imagine you can do all sorts of things with that, such as creating operable windows or doors to fit into your curtain wall system, even louvers or sunscreens. So I hope that was helpful. Next time we'll look at creating a door where we actually have to create some 2D symbology as part of the parametric cell.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.